We are going to learn about how absolute values can be used in word problems. Put it up. A machine fills Quaker oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. If the container's weight differs from the desired 32-ounce weight by more than 0.5 ounces, the container is rejected. So desired weight is 32 ounces. Write an equation that can be used to find the heaviest and lightest acceptable weight for Quaker oatmeal containers. All right, so they want it to be 32 ounces, but they said that it's okay if it's off by 0.5 ounces. So that means it's going to differ. The way we write differ is to find the difference. But it could be above or below, so it could be positive or negative. So we do absolute value of whatever the weight is. So we're going to call that X. Actually, I'm going to call that W for weight. Minus the 32. And it can't be off by no more than 0.5. So it has to be less than, let's see. So write an equation that can be used to find the heaviest and lightest acceptable weights. So we'd say it has to be less than 0.5. Oh, yeah, less than or equal to. All right, so that means I would write my two equations. So plus 32, plus 32. And then the other one, you also have to do plus 32. So negative 0.5 plus 32. It should be 31.5. So the acceptable weights are between 32.5 and 31.5. So remember how we graph these? Less than has the and, so that means I'm going to shade between. So if I have a number line, 31.5. So let's say this is 31, 32, and 33. Because I want whole numbers on my number line. And then I'm just going to place my circles where it would be 31.5. And it's going to be a closed circle because it's or equal to. So 31.5. And then 32.5. And we're going to shade between. This is the acceptable. So anything outside is unacceptable. So that's the heaviest and lightest acceptable weights. So it's between 32.5 and 31.5. Okay, at Brooks Company, the average starting salary for a new employee is $37,600, but the actual salary could differ from the average by as much as $2,590. Write an absolute value inequality to describe this situation. So it's going to be around 37,600, but it could differ by as much as $2,590. So it could be above or below. It could be either way. So we're going to do it like the previous one. The salary, so I'm going to call that S. could be different. So we're going to subtract 2590. Nope, wrong one. Sorry. 37,600. And it could be off by 2590. There we go. And we want it to be less than or equal to the 25,090. Because it says could differ as much as that 2590. So we write our two inequalities. So let's go down here and write those. Because with absolute value, you write your two equations. Okay, so let's solve each one. $40,190. Is that what y'all got? Okay. And then the other one. Really, we're adding the difference and then subtracting how much it could be different by. 35,010. Did that work out? Did the math work? Okay. So that means the acceptable salary range is between those two values. And it's a less than, so we're going to shade between. Okay, so these are, it's close to 40,000 and 35,000. So I'm going to put 35K here and 40K here. And then we'll put the number that it's close to. So like 35,010, it's just a little bit above. And it's a closed circle. 40,000, just a little bit above. And then shade. Okay, so let's look at our worksheet. Here it is. Okay, the first one you already know. Let's go to the second one, though. The first one's similar to the notes problems. The second one's a little different. Okay, a normal temperature for a pet lizard is 85 degrees Fahrenheit. If the temperature is more than 3 degrees away from this, the lizard could get sick. Write, solve, and graph an inequality to show when the temperature is unsafe for the lizard. Oh, all right, so let's see if I can write on this. All right, so whenever we write our inequality, we are going to have to do a little something different than what we previously did. If it's more than, then what inequality are we going to use? Greater than. So our inequality that we're going to use on this one is going to be greater than. So let me pull this up. So 85 degrees is our target. If it's more than 3 degrees, the lizard's going to get sick. So what variable do we want to use? Huh? T for temperature. So temperature varies more than 3 degrees, so minus 85, isn't it? There we go. And if it's greater than or equal, no, it'll be just greater than, wouldn't it? Greater than 3, it is not safe. Or equal to, we wouldn't use or equal to because at 3 degrees, it's okay. More than 3 degrees is not okay. So whenever we do this, this is a great or. So we are going to shade opposite directions. So I'm going to help you go ahead and solve this. So T minus 85 equals 3. And then T minus 85 equals negative 3. So solve those out. Draw your number line. So it says, show where the temperature is unsafe for the lizard. So it has to be within that 3 degrees. Unsafe is outside. So we're going to graph the unsafe. So we have 82 and 88. So unsafe is just the shaded area. The open circles is safe, so that's why it's not included. At 82 degrees, it's fine, but once it gets to 81.5, 81.9, it's unsafe. The lizard could get sick. Okay, so you have 4 word problems and then 2 just practice problems on solving. So it says read each word problem, write, solve, and graph the inequality.